Designing an enterprise database system. An enterprise database system is a complex and large software project. Building a new database is just as complex as any large software project, and it usually goes through the phases. All design processes are usually iterative processes. For example, the second phase may discover some inconsistencies of the first phase which may need to be fixed before proceeding further. Let us understand the database design life cycle. The first phase is requirement analysis. Each large software project involves requirement analysis to ensure that the software to be developed meets the requirements of the enterprise or the client. For a database system, requirement analysis involves fully understanding the requirements of the proposed system and describing them precisely, which includes the queries that are likely to be posed. These requirements must be explored in depth, ensuring that a clear and concise description of the requirements is prepared. The description should include all the properties of the objects of the interest, ways they are related to other objects, and frequency of access. Nature and volume of the transaction should also be explored and documented. Furthermore, the possibility of growth of the data in future should also be considered, and this can be very challenging. A requirement specification document should be prepared based on all this information. This document must be accepted and signed by both the parties, that is, the database designer and the client. Once signed, the document is then used in all the design phases that follows. The second phase of database design life cycle is data modeling. Once the first phase has been completed, the information content of the proposed database system is known and a requirement specification document is available. The information must be modeled using a data modeling technique. This is the most important phase of the database design because the quality of database system and its adaptability is often significantly influenced by the quality of the data model. This is elaborated in the next lecture, which uses a relatively simple modeling approach called entity relationship model. The primary aim of data modeling is to develop an enterprise view of the proposed database system with the ultimate aim of achieving an efficient database that is suitable for the workload and meets all the requirements. To some extent, data modeling and requirement analysis go hand in hand because data modeling can also assist in communications between the designer and the client because of the simplicity of its representation. The third phase is prototyping, which can be a very helpful phase of the design life cycle because it helps enormously in improving the communication between the designer and the client. A prototype should be quick and dirty implementation of a simplified proposed database in order to confirm the specifications developed in the requirement phase. What follows prototyping is implementation phase. Given the data model developed in the data modeling phase, which we assume is independent of the DBMS to be used, the model needs to be transformed using the DBMS that the enterprise has selected for the database. If the data modeling exercise of the last phase was successful, then the implementation should also be good. A suitable set of software tools should be available for users to enable them to use the system effectively. Following implementation is the need of testing. Just like for any software system, a database system must also be tested to ensure that the system is reliable, efficient, and correct, and it meets the demands specified in the requirements document. The testing phase should discover most of the errors that may have arisen during the modeling and implementation phases. Testing may also be used to show to the client how the system is likely to appear and perform. And last but not the least is the maintenance phase. In spite of thorough testing, any new database system is likely to have errors and omissions, and these need to be fixed during this maintenance phase. In addition, on using the system, the client will almost always come up with new demands that require modifications in the design and implementation of the system. Even if no new demands are made, the client might find that some database queries and transactions are not performing well and it needs performance improvement. The database administrator is of course in charge of resolving all such client requests. Maintenance of a system can become very expensive unless a system is well designed.